So after tomorrow, we will be on a 8-week review schedule, and that'll take us up to the week before the exam. The exam is on the 9th. That's a Tuesday. I'm pretty sure that's a Tuesday. I can't remember. It's either a Monday or a Tuesday. But that'll take us up. Now, some of those weeks have like a 2-day break on them, and so we'll have to adjust there. That'll probably, unfortunately for y'all, just take out the 2 work days that are there. But this is what we'll do, and every week will be the same. So Monday, we will review the practice test that we took on Friday. That's your major grade every week. On Tuesday's a work day. Wednesday is FRQ practice and discussion. So we'll do FRQ together. You'll do them alone, and then we'll talk about them together. Thursday is a work day, and Friday will be the practice exams, where I'll alternate. So I'll take like a previous exam, and on this Friday you'll have the multiple choice version of it. We'll talk about it on Monday. The next Friday you'll have the FRQ portion of it. We'll talk about it on Monday. Yes. That's straight up grade. So once a week. I know that's bad. Well, now we're done with everything. So now you've seen everything. Because if I don't, you won't take it serious. Okay, so after that, I'm telling y'all, I spent literally 4 hours coming up with it. I have everything down to the problems and what I'm giving you and how I'm grading everything. Because I need grades for you. Okay, so that's the way it is. It's the practice test. That's a major grade once a week. Half of an AP exam each week. Then in addition to that, so you've got these 2 work days each week. What are you doing during work days? Well, each week you have a Barron's assignment. There are 8. There are actually 9 units. We're skipping the first unit, 1 unit of all the multiple choice per week. So that gives you 3 hours class time. Depending on how you use your class time, you will have to work on some at home. You also have an AP classroom. One review session video per week. It's roughly an hour long. It's anywhere from 45 to 55 minutes. And then you have unit progress checks that begin in unit 1. So this is a weekly schedule for the week. This is a week's worth of homework. Plus you have 2 days in class to do it. So I've already assigned the very first week's worth. So if you want to get started on it, I'll release them on Friday. They will be due the following Friday by midnight. So is it harder to earn an A second half? No, as long as you put the work in on your end. No, what's harder is the... Okay, is it gonna like... It doesn't matter because that's all you'll have for the 9 weeks. So however they weight, they're all equally weighted. So it won't really matter. You won't have quizzes or anything like that, no. This is it. If you have C's, that will be your own fault. I'm going to post it for you. I'll post it for you. And the first week's already posted on Canvas. So if you look down in Canvas, it says review week 1, March 7th through 11th. There are the assignments that are due. You've already started unit 1 in Barron's, so you've already gotten part of that done. The video with the link, we're starting in review session 3 because they go derivative limits, and we were going to start with limits when we review. So this is broke down following the CED from College Board. So now we stop focusing as much on concept and we focus on what College Board wants us to do as far as testing goes. This is when we perfect our testing for the AP. Before we learned calculus, now we learned how to take AP. One video per week. Yes. You will have roughly 30 multiple choice questions. Those are taken for the grade that you get, yes. And the video, you get credit for watching the video. Practice test. And then I have already booked the lecture hall on Friday, April the 29th. I'm sorry. You will be excused from second block. we'll do the whole thing. We should be done by 12:30 or 1, depending. Do what? Yes, that'll be a full-fledged practice exam, and we'll run it just like the AP exam. Right. Each week we're doing 1 unit. Yeah. We'll see when I grade them the first time. We'll see when I grade them the first time. See how it goes. I've always curved your test and done whatever. I don't want you worried about the grade. I want you worried about the work. If you do the work, the grade will follow. Yeah. I didn't know I didn't have it up here, y'all. Why didn't y'all tell me I didn't have it up here? This is the more time consuming part of the semester, y'all. You should not spend more. It's very possible that it could be an hour on some days. It just depends on how you. I wouldn't, if you've kept up with everything and knowing what you're supposed to all along, this shouldn't take any longer than what it has in the past. Practice tests are old AP exams. I have exams all the way back from 2008. So I'll take an exam on Friday. We'll alternate the multiple choice and the free response. So, no, but I will. It's a true AP prior exam. It's not even a practice exam. It's an old exam. So, because it's an hour and a half, you'll have multiple choice 1 week, and you'll have FRQ the next week. On Mondays, that day is to talk about the prior week's practice test.
So when you find out my AP score, if I get a, then you must go and get a grade request. Grade change request form and change my grade.
Okay, deal. What good is it going to do you? You'll already be in college.
Well, it still help my.
So we'll review the practice test. So the first Monday we won't be doing this. And what y'all are losing sight of is I'm giving you 2 full days to work on this. This is not all homework. No. Your unit progress checks will be on unit 1. This is an actual practice exam. It's on everything. It's not even a practice exam. It's an old exam. I don't know. I won't know until I grade them. There is no way, y'all, how are you going to pass? Listen out, we've covered all the material now, and y'all are freaking out because I'm giving you practice old exams in class.
I get a 55, that's passing, but that's failing like 40.
I never said like a normal test. I said it would be great. I am not going to sit here and tell you how I will grade it because I will not know. That is my discretion, my professional opinion whenever I grade them. I'm not going to say I'm going to put this curve on it before I've even graded them.
Because the first one, it's like we haven't had any yet, really, ever since the first unit.
Right.
So it's
And the goal is that they progressively get better. If your grades are not progressively getting better, then something's wrong. Y'all go ahead and fuss and whine and hurl things at me. I can handle it. I'm a big girl. I have thick skin. It's okay. It's not going to change my mind or change anything about what we're doing. I am excited about the schedule. I think it is going to be the most beneficial for y'all. I think it's going to help too. Y'all are going to have to be self-motivated. This is where your self-motivation comes in. And I thought giving you 2 days every single week of nothing but just strictly working was pretty. That will not be graded like a major grade. That will be just like a daily grade. And it's going to be practice. And those will also come from old exams. And what we'll probably do is split up like we do for a test. We'll do a couple FRQs, then we'll come back together and we'll self-grade and discuss the FRQs that we just did. No, those will probably, to help you with the practice test more, those will be varying FRQs. Right. Correct. Yes. Which will be kind of like we did before, where I ran 2 FRQs, you did it, we came back together, we talked about it. There are some donuts back there, y'all are welcome to if you want some. Yes, absolutely, absolutely. And Monday, and Wednesday once we finish the FRQ. Right. Yeah. What? On Wednesdays?
I thought it was like one week for
Right. So I did, and I felt like I posted this, and I can't remember if I did or not. Let me see. When did I do it? Oh, I forgot to post your last minute advice. Are we gonna have what? I couldn't hear you. There's a possibility. Well, the good thing about the way that the class is laid out now is you won't have any problem. You know what I'm saying? This will start Monday.
I'm gonna be like missing Fridays. Like I have like a Friday.
You'll have to make up the practice exam. Yes. If you miss a Friday, it's just like a test. So you'll need to arrange a time to come in and make up the test. What? Well, technically, I can. If you can't come any other time, then you'll have to miss something during class, and then you'll have to make that up too. We'll see. Any other questions about the schedule? It's fine. I'm gonna post it too. We will. That's what I'm saying. It should have released at 8 o'clock this morning. Do you not see it? And there should also be a link there. If you go to the video, you can just click the link instead of logging on to if you want to. Yes, we do have a test tomorrow, the last bit of stuff. That's what, but I knew I couldn't talk about this tomorrow because you'd be testing. And I don't want to use up Monday to do it because I knew that there would be whining ensued. Yeah. Identify the indeterminate form. Is that what you're talking about? So you got the limit as x approaches pi of cosecant x over 1 plus cotangent. So if I just did a plug in there, what's the cosecant of pi? One over sine. What's the sine of pi? It's undefined. So I'm undefined up here, right? So I'm going to have to do a left hand and a right hand limit. So I've got to think about that graph of cosecant. There's an asymptote at pi for cosecant, right? Y'all remember what it does? And so from one end, L'Hopital's will. But the point of this is that you recognize you don't have to be able to do all this. You have to recognize that it's undefined. You would also recognize that down here is what? What's the cotangent of pi? And so I'm in an undefined situation in the bottom again, right? So you notice that I'm not going to ask you what the indeterminate form is. You're just going to have to recognize it is indeterminate. Indeterminate lends itself to using L'Hopital. But now L'Hopital means I have to take the derivative of cosecant 1 plus cotangent. So what is the derivative of cosecant x? I'm still undefined. No. Had I not? Yeah. Had I not posted the solution true? Okay. All right, so I can take the negative, I can take a cosecant, right? So now the limit as x approaches pi of cotangent x over cosecant x. Yes. And what is cosecant? 1 over sine. Does it help you if you do that? We've been long removed from limits. If cosecant is 1 over sine, remember limits, we try to manipulate any way we can to try to evaluate the limit. Did you get it right? So what's the limit as x approaches pi of cosine x negative 1? Now it's an easy evaluate. But we had to use L'Hopital's first. I'm sorry. I got to start getting y'all used to seeing. So. Now, if y'all want to use part of your workday one day to do something like that, those are your work days to use however you see fit. The limit as x approaches infinity with the direction state, use L'Hopital's to evaluate. 1 plus 2x. We're going to have to use the chain rule here. 2 log x. So it tells me to use L'Hopital's, so I'm going to use L'Hopital's. How do I take the derivative of that?
Yeah, there's an E in here. I know that.
Can you do that? Wait, I have to do. Yeah, sorry. Well, I just did power rule right there real quick. So bring it around front, subtract. Well, but you have to evaluate the limit. The whole point is that you evaluate the limit. This is going to cancel. This one's tough. Let me think of how I can write this differently. This is the same thing as 1 over log x squared. I don't know if that's going to help me any. Well, yeah, we're not going to be able to do power rule on this one. I would have this one in my calculator. Well, if you graph this and y equals, and then go as far as you can over with the x and see what it's approaching. There's probably going to be an asymptote there or something that it's approaching. No, but I think the problem with this book is I have not seen anything that involved on A-B level without a calculator. When you get into those exponents like that, yes. I would use my calculator. I'd have to look up how to do it without using a calculator on that one. I mean, I'm not going to lie to you. That's tough. Do you know how to do it, Dylan? Yeah. This L'Hopital's went a little beyond what I expected from y'all for L'Hopital's. I'm sorry. So the L'Hopital's you need to know how to do are the L'Hopital's that you will find like in your Barron's book that you will get to as we do those. Yeah, if you get to something where you're in a 0 over 0 or an infinity over infinity when you plug in, then you just use L'Hopital's and evaluate. Yes, top and bottom. Which one? It's the tangent of pi over 2 and defined. So if you took the derivative there, what happens? Come on, Josie, you know that. It's a constant. But I got to use that product rule here, so I'll have to do... And actually, L'Hopital's works when I'm in an indeterminate form of like a fraction, like infinity over infinity, right? So let's make this into a fraction. So pi over 2 minus, so you can do derivative of the top, derivative of the bottom, times sine y. Agree or disagree? So this would be sine y times pi minus 2y over 2 cosine y. And I'm approaching, is there any way, could I plug in now? Will it work if I plug in now? Sine of pi over 2 is defined, but the cosine of pi over 2 is 0, so no. Give me 0 over 0. Product rule is derivative of the first times the second plus the first times derivative of the second. So what's the derivative of the first? Yeah. We're not doing quotient rule, we're doing product. So derivative of the first times the second plus the first times derivative of the second. All over. Probably would have worked. I just wanted you to see the indeterminate form of 0 over 0. Now can you do pi over 2? If I plug in, let's see, pi over 2, 2, this is going to be 0. What's the sine of pi over 2? 1. So I get negative 2 over it always equals 1 or 0. You what? Just 1. Cosine, are you talking about taking a derivative? Give me an example again. Cosine of what? One over 1/2, like that. What's the exponent? All that is the exponent? You would, so if this was, is it a value down here or is it a function down here? Probably a function. So let's just say it was x raised to that. I would probably do power rule here. So I would bring this around here and I would subtract 1. But then I'm going to have to chain rule it. So I'll have to multiply by the derivative of, well, the whole thing and not. Does that make sense? Oh, I see. But I would try to work with this to get it as simple as possible first and see what happens. 9 times out of 10, something's going to cancel or work to make it easier for you in the end. Give me some cross sections or some let me unplug this. Particular.
Like when x is like negative 1 and 1, I mean, there's 2 x. X rotated around. No, I'm not talking about that. I'm talking about when it's like x is negative 1, x is like 3, and it's like y.
What are you revolving around?
You're not revolving around.
What are you doing?
You're finding the
Area with cross sections? What shape are you?
it doesn't matter.
Do it what? It's not revolving. This one's not revolving though. I'm gonna have to make this positive 1 because you can't go over in that other the way it is right now. But not with the function though, that's right. 1, 2, 3. Cross sections. So let's say, how do you know what? Well, you have to look at what you're rotating. That's with rotations. We'll talk about that. Okay. So that means I need this to be x equals the square root of y. So I need to find these points.
It was looking on the side, right?
Right.
So then if I'm doing it, if I'm graphing it, right, if my x's become y's, they x.
When you're graphing or when you're evaluating?
Graphing on the side.
Would your x's, you would have to keep your xx and your yy. Makes sense.
I mean, like, if I'm graphing x equals y.
Okay.
If I graph that, do I graph x equals 1 and x equals 3 or y equals 1?
Y equals 1 and y equals 9. Is it? Oh, no. You have to graph what it tells you to graph. The way it tells you to graph. It has to be x equals 1 and x equals 3. That's what it gives you. This would not be a problem that I would do with respect to y. Because your cross sections are going to run like this.
So when I do, if I'm doing
Because she said with respect to the y-axis, she said with respect to y. If it's ever with respect to y, that's the way your radius, if you're revolving, is going to look, and that's the way your cross section is going to look.
I'm confused on how to get how to kind of revolve it, how you get the whole.
Okay.
So round, am I equating right?
It depends on the way the question's asking you. If it says perpendicular to the y-axis, you're using x equals something. If it's talking about perpendicular to the x-axis, that's y equals something. So you got to look at how this is perpendicular to the y-axis. So that's with respect to y. This is perpendicular to the x-axis, so it's with respect to x. Which one? Are you looking at one in particular that was, because we don't have a whole lot of cross sections that are with respect to. Majority, 99% of your cross sections are going to be with respect to x. Your revolutions are when you're going to start really, revolutions in area are when you're going to start getting into with respect to y. But you could do it. You could do the cross sections with respect to y. So if I was doing this, if I said my cross sections were, say, just square, and that this is the base of the square with respect to y, right? My question is, what is this length? Which gets into the revolution whenever I have to think about what that length is. Well, from the y-axis here is the square root of y, but that's not what this distance is. What is that distance? All the way over here, all the way across is 3, right? So then the area of the square so then the volume using cross sections, because I'm with respect to y, has got to go from y to y. Can I? Yeah, I hope it finishes nicely because I made it up off the top of my head. So now antiderivative here. Now the variable itself doesn't matter. That's not going to impact. The whole point with respect to the variable is that I get the measurements right here. So now this is going to be 3y minus, nope, sorry. This y here. I'm going to have to FOIL that out before I can find antiderivative. Because all the way across, so from here all the way over is 3. It's a lot easier. Your length each time here is just x squared. So the side of the triangle, the side of the, yeah. Because up to that yellow line, because we're doing it with respect to y instead of with respect to x. If the question asks you with respect to y, that means your radius or your cross section is perpendicular to the y-axis instead of this way. Yes, that's exactly right. So now this is 9y minus 3y to the negative 1/2. Nope. 3 halves, right? Get that wrong. I'm anti-deriving. This is where you start getting mixed up. 1/2 plus 1 is 3/2. So I'm multiplying by 2/3. Plus half y. Yes. And all this is evaluated from 1 to 9. This one's a nasty evaluation because it's not got a 0 in it. I'll have to do both. You still need me to keep going? Okay. Yes. 21. On what?
You know it's from the y-axis to the yellow line and not the other way, not the yellow axis.
It always measures from the x-axis or the y-axis.
So that's why those like the x is going to be going from the yellow line to the x-axis.
Correct. So it always measures from the axis itself. And that's going to help you find your hole in your hole. What'd you say, 24? 21. The volume of a solid generated by revolving the region enclosed by the parabola y squared equals 4x. So I've got to do some manipulation here either way. It's got to be solved for x or it's got to be solved for y, one or the other. Okay. And the line y equals x about, and I'm going to do the x-axis and the y-axis. So let's just come here. I'm going to go ahead and just solve this for yes? Agree, disagree? Or 1/4 y squared? Zero, zero. Let's see if I plug in 1, I get 2, and I know that this is a, let's see, if I went 4, I would have 4, 4. Just trying to kind of get the shape of this. I'm going to do something like that. It is plus or minus, so it is. I don't know if this is enclosed by the parabola. So it's going to be enclosed. The other one, y equals x, is going to do something like this. So I'm talking about this. Keep straight which formula goes with which function, because that's going to be important as I decide what is what. So the very first question asked me to find the volume of the solid rotated about the x-axis. So I'm going this way, right? So I need my equation solved for y, and it is, so that's nice. So I got 2 root x and x. Yes. Okay. If I'm rotating this around, you have to determine, well, where is there no shading as this rotates around the x-axis? Where is there blank white space? From here to here, right? This is going to be my hole, which means this, right, is the hole. What top part above what line? The black line's the top of the... If this piece just twists around the x-axis like this, it's making this shape that's kind of being in. I see what you're saying. Yeah, no. Think 3-dimensionally, not 2-dimensionally. Can you see it now? Okay. So the radius of the hole is what? I'm with respect to x right now, right? And the radius of the H hole is just x. So the area of the hole pi r squared. It's a circle. It's a donut, remember. That's all the way to the center of the donut. Now I'm going to do the whole of the donut. So this would be pi x squared. I need these intersection points, and I need the x values. I know it goes from 0 up to, I need to know what that is. So, right, where does 2 root x equal, equal x? This is an easy one. I'm going through all this to show you, but realize some of them may not be this easy. So x equals 0, x equals 4 should be my two intersection points, right? You all see what I did? I just set them equal to each other and solved. If this goes to 4, because I'm with respect to x, I'm going to do w whole. So 4x, put that pi on the outside and don't worry about it again until you're done. Minus x squared, yes. Yes. I'm assuming the setup is what's hardest, not evaluating this integral like that. So let me set up all four of them for you really quickly so that you understand. Now let's rotate about the y-axis. Same setup, same scenario. And I'm going to go ahead and put a point with this. If x is 4, that means y is 4. Oh, thank you. This point is 4, 4. Okay. All right, so now if I'm going about the y-axis, so I'm flipping things around here. So let me come over. Now, I'm going, that's the whole thing, right? And that's the whole thing. But I've got to do it where my equation is solved for x this time. Because this distance is in terms of x. To find that length, it has to be x equals something. So here, I'm going to say x equals 1/4 y squared. Does that make sense to everybody where I got that? And this one's y equals x, so it is what it is. So the radius of the whole, so it's y. Remember, I'm with respect to y this time. And the radius of the whole and you know how to do from there. But you're going from 0 to 4 again. Yep. This one area, actually, let me write pi y squared. Area is pi 1/16y4. And then, so then it's, the pi's gone, it's y squared minus 1/16y to the 4th. Now you get into hard stuff. Yeah. How about if I do this? Yes. Evaluate from 4 to 0. Yep. Hard part here is the line, and so it says the line x equals 4. '21, yeah, about the line x equals 4. Here's x equals 4. Rotated about that line. Okay, so this is my whole. This is my whole. But remember, it's yes, because it's measured. Remember, it's measured from the axis. It has to be measured from the axis. So here, if I'm about the line x equals 4, then the radius of the whole thing, well, this whole thing, what is that length? Well, I don't know because I have to measure from here. Well, from here all the way across is 4, but then I take this little piece away, right? Why are you doing it with respect to y? It's a vertical revolution, right? The axis of revolution is vertical. If it looks like the y-axis, then it's with respect to the y-axis. Does that make sense? So what's the radius of the little hole? That's exactly right. Yes. Still from 0 to 4. Your bounds have not changed there. If you can get this part, the rest is downhill. Pi r squared, subtract the big one from the little one. The little one from the big one. You still have to measure from the axis. Yep. What if I changed that line to be, what's the name? Y equals 4. So what if this was the line? How do you know it's with respect to x? It looks like the x-axis. That's exactly right. So now, this is the piece that's revolving, right? So whole. Stacy. Whole. What was the one way? Yeah, right there. No, you're going to use the 2 root x. 2 root x. So my radius of my hole, did you say it's making more sense or it's not making any sense? Okay, so the radius of the whole hole, the big thing, all the way down, it's got to measure from the axis. So it's going to be 4 minus, and then what am I subtracting? X. That's exactly right. How about the radius of the white hole? That's it. If you can get that part, you can get the rest. The area of the hole would be pi times 4 minus x squared. The area of the h hole would be pi times 4 minus 2 root x squared. What? Pi r squared.
I was looking at the other one.
That's okay. Right? And so now it's the integral for the volume. 0 to 4 still. That has not changed. I put the pi on the outside. It's the w hole. This would take some foiling out minus the h hole. Now it's downhill.
The foil then inside the
Foil, yeah, foil and finite.